And another example I want to take here is evaluate limit x tends to 5, x minus 5 over x squared minus 25. So let me plug in the limit directly. What you get is 5 minus 5 over 5 squared. You just replace x by 5, right? So 25 minus 25. So you get 0 over 0, right? So which is indeterminate form. We don't know how much is that. So we will learn about that later, okay? But we don't know what is that. So in this case, you do not plug in the limit directly because 0 over 0 is not a right answer. It cannot be an answer, okay? So what do you see? What you do for this is you simplify the top and bottom. So what I do is limit x tends to 5 and then the top is x minus 5 already in the lowest form. Now get the factor of x squared minus 25. You can write x minus 5 and then x plus 5. You see that? Now this is x minus 5 divide x minus 5 is 1. You can cancel that out. And what is left is limit x tends to 5, 1 over x plus 5 is left. Okay? So now the next step is just plug in x equals to 5 there. 1 over 5 plus 5 is 1 over 10. Okay, so this is slightly different from the previous problem. What is the difference there is when you plug in the limit, you got 0 over 0 form. There is a rational function, meaning there is x in the numerator and x in the denominator. When I plugged in the limit at the beginning, I got 0 over 0, which is not the right answer. So what you do, you simplify, you factorize, you simplify, okay? You simplify and then you cancel the factor, one of the factor common, that is common to both top and bottom. And then what is left, you plug in the limit there, okay? That's what the rule is. To find out the limit x tends to a f x, plug in x equals to a. If it is finite, you are done. That's what we got in all these three examples, okay? And then if you get 0 over 0 form, that is the last example we did, simplify the numerator and denominator for denominator and get the lowest form. We simplify the numerator and denominator and then we cancel out and then we got the lowest form. This is the lowest form, right? And then plug in the limit. If this limit is finite, then it is the limit, right? If it is not finite, then it is either infinity or limit does not exist. So for the infinity limit, we call infinite limit. We will discuss that later. For now, if it's infinite, we say limit does not exist for now, okay? But in the next section, we will see infinite limit, okay? But for now, if you get 0 over 0, you will have to simplify and then get the lowest form. If the lowest form is of after you plug in the limit in the lowest form, if it is finite, the limit exists. If it is infinite, then the limit does not exist. Okay. The next rule is sometimes you get radicals, meaning the root in the numerator or in the denominator. Then in that case, you may have to use the conjugate multiplication. So next example is we will have to use conjugate multiplication where the numerator or the denominator has the root in it. Okay, look at this example that that is a limit. Find the limit x tends to 22, x plus 3 minus 5 divided by x minus 22. If you plug in this limit directly, what do you get? You get 22 plus 3 is root 25. That is 5 minus 5 is 0, right? You get 0 on the top. And 22 minus 22, 0 on the bottom. So this is not the right answer, right? So 0 over 0 cannot be the answer. What you do now, try to simplify and get the lowest form, but it is hard to get the factors on the top and bottom as in the previous example, right? What we do, since there is a root, as the last rule suggested, what you do is you multiply by the conjugate, right? So what you do here is write down that limit x tends to 22 root x plus 3 minus 5 divided by x minus 22, okay, times conjugate of the numerator or denominator. What we do here usually is if there is a root in the numerator, you multiply the conjugate of the numerator. If there is a root in the denominator, you multiply by the conjugate of the denominator. Okay, that's what you do. So what you do here is root x plus 3 plus 5 over root x plus 3 plus 5. Okay, now you multiply the top, it is like a minus b times a plus b. You can FOIL it or you can use that formula. Okay, you can FOIL it, that is perfectly fine, or use the formula a minus b times a plus b is a square minus b square, right? Do you remember that formula? That formula is basically a plus b times a minus b. If you multiply that, you will get a square minus b square. That's the formula that I want to use here. So what you get there, then you get limit x tends to 22. It is like a minus b, a plus b, a square will be x plus 3 only, right? Because square of the square root will be just square and square root will cancel out. Minus 5 square is 25. Divide by, let me keep that, x minus 22. I don't want to FOIL the denominator. I just keep it for some time. Root under x plus 3 plus 5. Okay, so what do you get in the top? If you simplify, you will get, this is basically x plus 3 minus 25, right? Basically x minus 22. So limit x tends to 22, x minus 22 on the top, and then you got x minus 22 on the bottom, and then there is one more factor on the bottom, x plus 3 and then plus 5. You cancel that out, divide by x minus 22. So you got 1 over, so let me write down limit x tends to 22, 1 over x plus 3 plus 5. Now you plug in that x tends to 22. After you plug in, you don't have to write the limit. Okay, so what you get is 1 over root under 22 plus 3 plus 5. You see that? So 1 over 22 plus 3 is 25. So root 25 is 5, right? So 1 over 5 plus 5. So your final answer is 1 over 10. You see that? So sometimes you may have to conjugate by the conjugate of the numerator, or sometimes if it wasn't the denominator, you would do conjugate of the denominator. So that is another way of simplifying the rational function, okay, by multiplication of the conjugate. So that will cancel that term that create 0 by 0. Okay, so let me take one more example. So that example I want to do is example. So what I want to do is find limit delta x tends to 0. Instead of x, we have delta x here, but it is not a problem at all. Okay, f of x plus delta x minus fx over delta x for fx equals to 6x square minus 4x. For this function, I want to find out f of x plus delta x minus fx over delta x. How do I do that? Let me do this problem. So solution is limit delta x tends to 0. You want to find out f of x plus delta x minus fx over delta x. That's what you want to find out, right? So what is the value of f of x plus delta x? Let me write limit delta x tends to 0. What is the value of f of x plus delta x? You just replace x by x plus delta x, right? What you get is 6x plus delta x square minus 4x plus delta x. This is the value of f of x plus delta x, because f of x is that, right? You replace x by x plus delta x minus, what is fx? That thing, right? You do 6x square minus 4x divide by delta x. Now let me continue right here, equals to limit delta x tends to 0. Now you simplify that. You get 6 x plus delta x square is x plus delta x times x plus delta x, right? X plus delta x times x plus delta x minus, you distribute that 4x plus 4 delta x, 4x plus minus 4 delta x. You see that? Because you need to distribute that, you distribute that negative 4. Okay, so minus 4 delta x minus 4 delta x, and then you distribute that negative sign as well, negative 6x square, and that will be plus 4x divide by delta x. You see that? Now what you do is, you see that negative 4x and positive 4x cancel out, negative 4x and positive 4x. Now these terms will not cancel out, they will still be there. Now you need to FOIL that x, you keep 6 and you FOIL that. What do you get? You get limit delta x tends to 0, 6. So this will be x times x is x square plus x times delta x, x delta x, plus x times delta x again, x delta x, plus delta x square. You see that? And then what is left is negative 4 delta x minus 6x square divide by delta x. Now you simplify the top, you will get limit delta x tends to 0, 6 x square. I'm distributing this 6. Now what is that? This term is x delta x, this term is another x delta x. So if you add, you will get 2x delta x, right? But if you multiply by 6, you will get plus 12x delta x. You see that? Plus delta x square minus 4 delta x minus 6x square. Now you cancel that negative 6x square and positive 6x square. What is left is 12x delta x plus delta x square minus 4 delta x. And then there is delta x in the denominator. If you plug in the limit right here, you will get 0 over 0. Okay, if you plug in the limit, for example, you will get 6, this will be 0, right? Delta x square will be 0. So 6x square minus 4x, and then minus 6x square minus 4x. That will be 0 over 0 when you plug in the delta x tends to 0. Now, what is left here is 12x delta x plus delta x square minus 4 delta x. Now, let's take delta x out. Limit delta x tends to 0. I want to take delta x out. What is left is 12x plus delta x minus 4 divided by delta x. You cancel that delta x and delta x, and when you take the delta x tends to 0, that will be 0 as well. So what is left is 12x minus 4. You don't need to write the limit because you plug in that delta x tends to 0 here. So 12x minus 4 is the final answer for this. Okay, so if you have this type of problem where you don't get scared, so don't get scared with this. Just plug in the value of f of x plus delta x. That replace x by x plus delta x, and then minus fx. Just plug in fx divided by delta x, and then you simplify. And then when you plug in the limit right here, you will get 0 over 0. But you simplify and then cancel the terms that can be cancelled, and can take the delta x out and cancel that delta x out, the factor out delta x and then delta x in the denominator, and then plug in the limit. And then you don't get 0 over 0. So that will be the final answer. Okay, guys.